All right, in the first part of 2.7, we are going to take a look at horizontal and vertical shifts of functions. So the entire goal of this section is going to be to look at all different shifts that we could do to any function. So this is a generic setup of the four different types of shifts that we're going to look at. What we're going to look at today are just actually the last two, C and D shifts. So in this big setup here, if we have a value here, this is a horizontal shift. And if we have a value here in our function, that is a vertical shift. So first, let's take a look at vertical shifts. All right, if we are adding a value onto a function, that's going to shift the graph up that many units. If we're subtracting a value, that's going to shift the graph down that many units. Okay, and here's a generic picture, right? They use the value C in this picture instead of D, but it's the same idea. Okay, if I'm adding something outside of my function, okay, and what I mean by outside of my function, right, we can illustrate in this next example. So let's say that our parent function is y equals x squared, okay? And the reason that it's going to be so important to memorize what these graphs look like is to be able to perform all of these transformations, okay? So I mentioned in the last section, we really need to have these graphs memorized, okay? So here is what our graph of y equals x squared looks like. If I'm adding 2 onto that, right, all that's going to happen is I'm going to take this original graph and move everything up 2. It's a vertical shift up 2. So instead of my vertex being at 0, 0, my vertex is now at 0, 2. Okay? And then I can graph the rest of these points. Okay. Then, if I want to have a vertical shift down, same idea. All I'm doing is taking my vertex and going down 4 units, and then every other coordinate point would be shifted down 4 spots. And so we would end up with something like this. Okay, now when you are graphing these, both for homework and on a test, I'm going to expect you to be pretty accurate with these, okay? Because part of this portion of our textbook is memorizing and understanding what our parent functions look like, okay, with specific points, okay? And if you don't remember what exactly it looks like, you can always plug a few values in, okay? So I am going to expect you to be pretty accurate when you're sketching these graphs. So you're going to want to use graph paper whenever you're asked to graph anything in the homework assignment, all right? So we can also go backwards and kind of say, well, given this equation, what's going to happen? We can write out an explanation. So let's say our original function is f of x equals x cubed, and then my new function is x cubed plus 1, right? Well, we want to actually write out what happened to my original graph, right? So I'm just going to write out, I'm going up 1, right, from my original graph. Now, what happens from this graph? Okay, so we're still saying we're starting with f of x. What did we do to get to h of x? Well, since I'm subtracting 3, I'm going down 3. Okay, so we're just verbally explaining what's going on, right? So the second type of shift that we're going to look at is a horizontal shift. Now, this is whenever we are adding or subtracting something inside of a function. All right, and we'll look at a couple of different examples of what that means here. Now, we have to be careful here, right? If I am adding a value inside, that means I am shifting to the left, okay? It's kind of counterintuitive. If I'm adding a value, that means I'm going to the left. If I'm subtracting a value inside of my function, that means it is moving to the right. Okay? So if I'm adding a value inside, that means I'm going left. If I'm subtracting a value, that means I'm going to the right. All right. So again, let's take a look at a few examples. So let's say that we want to start with the graph of the square root of x. Okay, so again, we need to know what that looks like. Right? We're starting at 0, 0, then the point 1, 1, then the point 4, 2 is on there. Right, we could even go out to 9, 3, but that would be off of our little graph here. Okay, but this is what that square root function looks like. Okay, and remember, we can't take the square root of a negative number, so there are no values over here. The graph just starts at 0, 0 and moves to the right. So let's take a look at shifting that graph. So here we've got the graph of y equals the square root of x plus 5. Okay, I've got a plus 5 inside of the function. This is what it means to be inside of the function as opposed to adding or subtracting something outside of the function. So plus 5 means I'm going left 5. So instead of starting at 0, 0, I'm going to go 2, 3, 4, 5 and start here at negative 5, 0. Then the rest of the graph is going to look the same. Right? So then 3. So here is what that graph would look like, shifted 5 units to the left. Now let's try to combine both a horizontal and vertical shift here, right? So this is saying I want to go to the right 2 and up 1. So my original starting point of 0, 0, I'm going to go right 2 and up 1. And then from there, I can plot my next couple of points. So here would be the graph of the square root of x minus 2 plus 1. Okay, so we just combined a horizontal and a vertical shift. Right? So let's do the same thing we just did with vertical shifts, describe these transformations. So let's say my original function is 1 over x. Now, my g of x is 1 over x minus 3. Even though we don't have parentheses or a square root or something here, this is still considered to be inside of the function. Okay, so this, my denominator is my inside of the function here for 1 over x. So here, this would really be taking my original graph and going right 3. All right, so let's look at one that has both a horizontal shift and a vertical shift. So here I would be going left 2 and down 4. Okay, so our final example then is just given a description, write the equation. Right? So let's say that our original graph is the absolute value of x, right? And I want to shift that left 5 units. So left is going to be inside of my function, right? So my new function, they didn't specify what to call it, but I'll call it g of x, is going to be the square root of, and if I'm going to the left, that means I'm adding. So I'm going to have the absolute value of x plus 5. All right. Now, for my second example, This is saying we want to take the cubed root of x and go right 2 and down 9. So right 2 means I'm going to be subtracting 2 inside of the function. So this will be the cubed root of x minus 2. I'm going to the right, and then I'm going down 9. So outside of the cubed root then, I will be subtracting 9. All right. So that is it for this lesson. The final question is going to pop up asking you if you have any questions.